Hello. So in my last video, I talked about the quotient rule and sort of gave a generalization of how it could be used to find derivatives. In this video, I'm actually going to give an example. So we're going to be taking the derivative. Oh dear, I'm going to use a different marker for this. The derivative with respect to x. We're paying attention to x, to delta x's, dy over dx, of the tangents of x. And this may not pop out immediately as a quotient rule problem, but as you'll see, it actually is. This is the same as taking the derivative of the sine of x over the cosine of x. And we'll have videos on that in the future. Now, what do we remember from the quotient rule, or really just the product rule? Well, I'm going to turn to the product rule first to solve this. So, we take the derivative of the first function, sine of x, which is cosine of x, and multiply it by the second function. That's 1 over the cosine of x. I'm not going to simplify anything yet. We don't change anything. Then we add. I'm really just showing that we don't need to use the quotient rule and that we can use the product rule to solve this, though it is a quotient rule problem. It's really essentially the same thing. Plus, the first function, sine of x, times the derivative of the second function, which is 1 over cosine of x. Now how do we evaluate the derivative of the second function, which is, if you come over here, our second function is the cosine of x to the negative first power. It's a really bad marker. Can you see that?
Mm-hmm.
Alright, so using the chain rule, we treat this as x. I'm going to stop, actually breaking it down so that we can get some practice visualizing it this way. We pretend this is x and only pay attention to the outside and use the power rule. So that's negative cosine of x to the negative second power. This is just the derivative. Here, I'll write it out. Is equal to, then we multiply times the derivative of the inner function, which is negative sine x. Alright, so pull back over here. Which marker? Blue. So, oh, no, we're not even done up here. Sine of x times the derivative of this, which is, alright, sine of x over cosine of x squared, because these two negatives cancel out, and this is to the negative second, which means 1 over that to the second, over cosine of x squared, or you could write cosine squared of x. Alright, what does that give us? This gives us the cosine of x over the cosine of x, which is just 1, plus sine of x squared over the cosine of x squared. And you could put the squared between the sine and the x and the cosine and the x, but it's really more intuitive to think of it this way. And then we turn this one, we get like terms for this one, like denominators. So this is equal to, come down, the cosine of x, cosine squared of x, or let's keep doing it the same way, over the cosine squared of x, plus the sine squared of x over the cosine squared of x. And this can be simplified too. Alright, we're almost there. Now, what is cosine of x squared plus sine of x squared? Well, we just need to think about trigonometric identities. Cosine of x squared plus sine of x squared is 1, just by the Pythagorean theorem in a unit circle. Alright, so that gives us 1 over the cosine of x squared, and we know this to be the secant of x squared, and that is our answer. I need to bend all the way down. That is our answer. Maybe I should start writing a bit smaller on the board. Thank you.